Hi, welcome to the company. I am your interviewer and I will interview you about the position of data scientist. Today I will ask you some interview questions regarding probability, probability distributions, hypothesis testing, and statistics. Are you ready? Yes, I'm ready. So the first question is a probability question. So imagine that there is a fair coin, one side heads, one side tails, and an unfair coin which has both sides being tails. You pick one at random, flip it 5 times, and observe that it comes up at tails all 5 times. What is the chance that you are flipping the unfair coin? Thank you. I think we can use Bayes' theorem here. I will let you denote the case where we are flipping the unfair coin, and F denoting the case where we are flipping a fair coin. Since the coin is chosen randomly, we know that the probability of U and the probability of F are both equals to zero point 0.5. And let 5t denotes the event where we flip 5 heads in a row. Then we are interested in solving the probability of PU conditioned on 5t, which means the probability that we are flipping the unfair coin, given that we saw 5 tails in a row. Now, we know the probability of 5 tails conditioned on U is equal to 1 because by definition the unfair coin will always result in tails. Additionally, we also know that the probability of 5 tails given f is equal to zero point 0.5 to the power of 5, which is equal to 1 over 32 by definition of a fair coin. So by Bayes' theorem, we have the probability of u conditioned on 5t is equal to the probability of 5t conditioned on u times probability of u divided by the sum of probability of 5t conditioned on u times 5 times probability of u and the probability of 5t given f times the probability of f, which is equal to zero point 0.5 divided by the summation of zero point 0.5 and zero point 0.5 times 1 over 32, which is equal to 0.97. Therefore, the probability that we picked the unfair coin is about 97%. Thank you for the answer. My next question is also a probability question. Say you draw a circle and choose two chords at random. What is the probability that these chords will intersect? Now, by definition, a chord is a line segment whereby the two ends points lie on the circle. Therefore, two arbitrary chords will always be represented by any 4 points chosen on the circle. If you choose to represent the first chord by two of the 4 points, then we have the binomial 4C2, which is equal to 6 choices of choosing the 2 points to represent chord number 1, and hence the other two will represent chord number 2. However, note that in this counting, we are duplicating the count of each chord twice, since a chord with n points P1 and P2 is the same with a chord with n points P2 and P1. Therefore, the proper number of valid chords is 1 half of 4c2, which is equal to 3. Among these three configurations, only exactly one of the chords will intersect. Hence, the desired probability is 1 over 3. Thank you. My next probability question is as follows. What is the expected number of coin flips needed to get two consecutive heads? Thank you for the question. I will denote x as the number of coin flips needed to until we get two heads. Then we want to solve for the expected value of x. So I will let h denote a flip that results in heads, and t denotes a flip that results in tails. Note that the expected value of x can be written in terms of the expected value of x given h and the expected value of x given t, which are the expected number of flips needed conditioned on a flip being either heads or tails respectively. So conditioned on the first flip, we have the expected value of x equal to 1 half times 1 plus the expected value of x given head plus 1 half times the summation of 1 and the expected value of x given tail. Note that the expected value of x given tail is equals to the expected value of x, since if a tail is flipped, we need to start over in getting two heads in a row. To solve for the expected value of x given head, we can condition it further on the next outcome, either heads hh or tails ht. Therefore, we have the expected value of x given h is equals to the 1 half 1 plus the expected value of x given hh plus the 1 half times 1 plus the expected value of x given ht. Note that if the result is hh, then we have the expected value of x given hh is equal to 0, since the outcome was achieved, and that the expected value of x condition of ht is equal to ex, since the tail was flipped. We need to start over again. So the expected value of h given the expected value of x given h is equal to 1 half 1 plus 0 plus 1 half 1 plus expected value of x, which is equal to 1 plus 1 half the times the expected value of x. Plugging this into the original equation gives us the expected value of x is equal to 6 coin flips. Thank you for your answer. My next question, I will select this the following question. You have two people, A and B. They are playing a game where A has n plus 1 coins and B has n coins, and they each flip all of their coins. What is the probability that A will have more heads than B? Thank you. Thank you for the question. So consider the first n coins that A flips versus the n coins that B flips. There are three possible scenarios. Scenario number one, A has more heads than B. Scenario number two, A and B has an equal number of heads. Scenario number three, A has less heads than B. Notice that in scenario number one, A will always win irrespective of the coin, whether it has coin n plus 1. And scenario number three, A will always lose whether it has coin n plus 1 or not. By symmetry, these two scenarios have an equal probability of occurring. Denotes the probability of either scenario as x and the probability of scenario number 2 as y. Now we know that 2x plus y equal to 1, since these three scenarios are the only possible outcomes. Now let's consider coin n plus 1. If the flip results in heads, with probability zero point 0.5, then A will have won after scenario number 2, which happens with probability y. Therefore, A's total chances of winning the game are increased by zero point 0.5y. Thus, the probability that A will win the game is x plus 1 half of y equals to x plus 1 half 1 minus 2x, which is equal to 1 half. Thank you very much. I will have my next question um, as follows. My next question is: a fair die is rolled n times. What is the probability that the largest number rolled is r for each r in 1.1 to 6? So to repeat, a fair die is rolled n times. What is the probability that the largest number rolled is denoted by the letter r for each r in 1 to 6? Thank you for the question. I will let B be the events that all n rows have a value less than or equal to r. Then we have the probability of BR equal to R to the power of n divided by 6 to the power of n. Since all n rows must have a value less than or equal to R, then I will let A be the event that's largest number is R. Then we have BR equal to BR minus 1 union with AR. And since the two events on the right hand side are disjointed, we have the probability of BR equal to the probability of BR minus 1 plus the probability of AR. Therefore, the probability of A is given by the probability of AR equal to the probability of BR minus probability of BR minus 1, and that is equal to r to the power of n divided by 6n minus r minus 1 and to the power of n divided by 6n. Thank you for your uh, answers. Now I have finished my interviews on the probability sections. So we will take some rest around 5 to 10 minutes, and then I will interview you about the statistics questions. Thank you again.